In lesson 3.2, you prove theorems based on the corresponding angles theorem. We're going to start to move through these a little more quickly because you're going to find they work very much the same as the last theorem, and they apply to situations very similarly. We're going to use what we found in the last lesson, working in the opposite direction, just to show that lines are parallel. This theorem, 3-5, is the converse of the alternate interior angles theorem. It states that in this case, using this diagram, if angles 4 and 6 are congruent, then we know that lines L and M are parallel. Theorem 3-5, the converse of the alternate interior angles theorem. Theorems 3.6 and 3.7 coming up. I think these are great to screenshot. They have the diagrams for you as well. Theorem 3.6 is the converse of the same side interior angles postulate. It states that if two lines and a transversal form same side interior angles that are supplementary, then the two lines are parallel. So in this case, here would be our same side interior angles, 3 and 6. If those two are supplementary, then lines L and M are parallel. If we knew these other same side interior angles were congruent, then we could use Theorem 3.6 as well to show that lines L and M are parallel. Theorem 3.7, the converse of the alternate exterior angles theorem, states that if two lines and a transversal form alternate exterior angles that are congruent, then the two lines are parallel. So alternate exterior angles, like angles 1 and 7 shown here, if we know that those two are congruent, then lines L and M are parallel. Vocab coming up, flow proof. Your only vocab terms for this section. The proof of the converse of the alternate interior angles theorem below, or on the next slide, looks different than any proof you've seen so far in this course. You know two forms of proof, paragraph and two-column. You're about to learn a third form called a flow proof. In a flow proof, arrows show the logical connections between the statements. It's much like a flow chart. Reasons are written below the statements. So let's take a look. Here's the proof of Theorem 3-5 as a flow proof. Remember, this is the converse of the alternate interior angles theorem. And here we're given that angle 4 is congruent to angle 6. So these are alternate interior angles. Our job is to prove that line L is parallel to line M. So we have our given information and what would normally be the next statement in our proof, whether it was a paragraph proof or a two-column proof. And what we see is that these two things together allow us to make the next statement. And that's something we've seen in our two-column and paragraph proofs, is that we often end up using multiple statements from above to contribute to the next statement below. This really shows us visually where this information comes from, what it's based off of. And then knowing this, we can flow directly to what we were asked to state in the end, that L is parallel to M. So just a different form of proof. Problem 2, writing a flow proof of Theorem 3-7. So here we're given angles 1 and 7 are congruent. We're asked to prove that lines L and M are parallel. And we're using the flow proof style. So we begin with what's given, just like our other styles of proof. And then our next statement, we would state that angle 3 and 1 are congruent. 3 and 1 are congruent. We know that because they're vertical angles. And that's our reason here, below the box that is our statement. That's another thing I kind of skimmed over, is that notice each of these has a statement in a box, and then the reason or the justification written right below it. So our given information and what we've shown here using vertical angles both contribute to or allow us to make the statement that angles 3 and 7 are congruent, 3 and 7, by the transitive property of congruence. So since angle 1 is congruent to 7 and angle 1 is congruent to 3, we can leave out that middleman, as I keep saying, and state directly that 3 and 7 are congruent. And that's, again, the transitive property of congruence. And then given all of those statements, we can now say that lines L and M are parallel. your got it question, a flow proof.